look at this next one, letter C. This looks scary. Okay, so I'm going to ask you a couple of questions. Can you take the cube root of -8? I hope you all yelled at me in the camera, yes, Miss Torres, it's -2. Oh, so I can take a cube root of a negative? Yes, Miss Torres, because it's a odd root. Ooh, you guys are geniuses. So the question is there any number I can't take the cube root of? No, Miss Torres, you can take the cube root of anything. You're a genius. So if anything can go in here and it'll work, and I can add 1 to anything, then this domain is all reals. And of course, if I write that in interval notation, it's -infinity to +infinity. I bet I got you on that one. I bet that was a trick question for you, wasn't it? Huh? Am I right? Am I right? Okay, moving on to the next question. Okay, so I raced ahead a little and got a head start on you. So f plus g of x is nothing more than adding the two functions. And of course, I'm going to need a common denominator. So I'm going to get that. So I'm going to multiply that first fraction by my favorite number 1, because Mrs. Torres is number 1, which is x over x. And then I have x squared over x plus 1 over x. So that simplifies to x squared plus 1 all over x. And so then I go, oh my gosh, this has no numbers. What number could I not use? Oh, I can't have 0 in the denominator, so x cannot be 0, which means when I'm looking for the domain, anything except 0 works. So -infinity to 0, open at 0 because I can't use it, or 0 to +infinity. Awesome, awesome. Okay, so next we're going to do the division, and I'm going to erase all this stuff. Okay, so f of x over g of x. Ooh, that's kind of looking scary, isn't it? And I go, no worries. I can't have fractions and fractions, so I'll just multiply top and bottom by an x, because that'll make these ones magically disappear with my Harry Potter wand. And so I end up with x squared. And so now, is there any number I can't put into x squared? Any no numbers? It's a parabola, right? So this one has a domain that's all reals. Again, -infinity to +infinity. Next question, please. So on this next one, before I do the composition, f of g of x, I just want to remind you that if I said find f of 3, hopefully, if I asked you, what do you do? How do you find f of 3? You'd say, well, I plug 3 in for the x. Good answer. How do I find f of g of 3? Well, the issue is, before I can do f of, I need to know what's g of 3. So I'd have to plug in 3 to the g function, right? And then whatever that answer is, I'd plug that into the f function. And if I said over here find f of a, well, I'd plug a into the f function. Makes sense, makes sense. And then if I said find f of g of a, well, before I could do f of anything, I got to find what's in this parentheses. I got to do this first. So I'd have to find g of a first by plugging a into the g function, and then after I got it, I could plug it into the f. And so that's exactly what I'm doing. I want to find f of g of x, so I have to do this first. So g of x is just this. That's as much as I know about it. I don't have any numbers. And now I'd like to find f of that, but the f function says that I'm supposed to do sine of whatever's in parentheses. So I'm doing sine of 1 minus the square root of x. So of course I know that this square root has to be positive. So x has to be greater than, or it could be equal to 0. So as far as what can I put in for x? Well, anything I want, as long as x is greater than 0 or equal to. So in interval notation, that would be 0 inclusive to infinity. So now I'm switching and I'm doing the g of f of x like it says. And so this time I have to know f of x first. Well, I know that. It's sine of x. And so I'm going to take g of that, but now I'm supposed to put that into the g function in place of the x. And of course I know that the stuff under the radical has to be positive. And if you remember correctly from your Algebra Students Take Crack